Hello dear students, today I'm going to discuss the most asked out by JEE aspirants, and with this one video all your doubts will be resolved. Okay, so let us move on to this question. A bottle has an opening of radius A and length B. Okay, so this bottle has an opening of radius A and length B. A cork of length B and radius slightly greater than this bottle. Okay, this cork is a little bigger, is compressed to fit in the opening completely. So this cork is compressed and fit in this opening completely. If bulk modulus of cork is B and friction coefficient is mu, so the bulk modulus of this cork is capital B and friction coefficient between these two is mu. Okay. The force needed to push the cork into the bottle is dash. So this, you see this yellow arrow, no? This is the force which is required to push the cork into the bottle. So what is this force? This is what we need to find out, and he has given four options. He has given. We need to mark the correct option. Okay. So let us move on to the solution. Okay. So let us analyze what is going on here. Okay. See, as you are pushing it, no, the volume of this cork is decreasing. Because its volume is decreasing like this, there are restoring forces inside the cork in this direction. So this, which is pushing the bottle. So the bottle applies a normal pushing force in this direction. Okay. So the blue arrows that you see here are the normal force applied by bottle on the cork. Okay. Now, as you are pushing the cork down and there is friction here, friction acts upwards. Okay. So if we have to find what is this force, basically we need to find what is the friction force. Once we find friction force, that is the same force that we need to push this cork into the bottom. Okay. So let us move on to the solution for this. Okay. See, I've drawn two diagrams. This is initial and this is finally when the cork is inside the pushed inside the bottle. Okay. Let me mark a few things here. Okay. So this initially, the radius was a plus delta a. Okay. Initially. Finally, what is the radius? Here the radius is a. Okay. Let us mark the length also. This length is b. And finally, the length remains the same. The length is b. Okay. Next, this is what we need to find, the force applied by us, some F. Okay. Force by us. This white color that you see now is the friction force. So let us mark the friction force. So this is friction. Okay. Next, these blue arrows that you see, normal force. Okay. I'm just writing it here. This is the normal force. Okay. Now you see this force must be equal to friction. So I'm just writing that here. This force F must be equal to the friction force. Okay. And what is this friction force must be equal to? Mu times normal reaction. Okay. Mu times what is this? Total normal reaction. Now let us move on how to find this normal reaction. We know that the bulk modulus is delta P divided by delta V by V. Okay, that means the pressure. If it is compressed by volume, what is the pressure exerted? So this delta P equal to B delta V divided by B. So what is this delta B? B times, what is the change in volume of the cork? Initially, the dimensions were this. Finally, the dimensions are radius A and height B. So the change in volume from here to here is the, so I'll just write that here, 2 pi A. So 2 pi A into thickness, that is delta A into B. Okay. So this is the change in volume from here to here. What is this V? V is the initial volume. So divided by initial volume is pi A square into B. So we can find out what is delta B from here. So delta B equals to, I will just cancel out this pi AA and B here. So we get this as 2B delta A divided by A. Okay. So this is the pressure, extra pressure. Now let us take a small area here, okay, on this cork here. If we take a small area here, what is the force applied? Force is pressure into area, right? So the small normal force that is applied here is this pressure into this small area. Okay, so the friction force here will be mu times the normal here in this small area. Okay, so what we'll do is, so the total friction force will be mu times the total normal reaction. So I'll just write it here. F equal to mu times the normal reaction is, see this is a pressure, okay. So pressure is 2B delta A by A into what is the total surface area? Tell me, this acts on the surface area, right? So that is nothing but 2 pi A, okay, into B. Okay, so I can cancel out this, and so finally I get F that should be applied equal to 4, so 2 to 4 pi capital B mu A times delta A into B. Okay, so fine, so we get this as the answer, 4 pi B mu capital A delta B delta A into B. Okay, so I hope you all have understood this question with this beautiful visual. Okay, and see you all in the next video.